So last 2 days I've done a little bit of breach coding, so taking unstructured breach data and converting it into breaches. But today I wanted to actually um, take that data and convert it into an actual data frame, so tabular data, and then do a little bit of analysis on it. And this is kind of to give people an idea of what it takes to just use kind of the tools that are freely available to do analysis. And so there's a couple of things you have to have installed to do this. The first is the R programming language, which you can get at rproject.com or .org. It's a programming language. It's the best description of it is maybe if you had Python, but it only worked on tables of data. And that's not exactly right. R is basically a statistical programming language. It's meant in many ways to model operating system commands, so you can use ls and things like that. And it's modeled on a former language called S, except that R is now open source and anyone can use it. And so you have to install the language itself. And then we also need an interface. You could work with it at the command line and get kind of an interactive shell. But, is that really what you want to do? And so instead, maybe it's better to get a good UI. And there's a couple that you can use. RStudio is a very popular and common one. Recently, I've been leaning more toward Jupyter notebooks, just because they're a little bit cleaner, easier to share, easier to store both analysis, or the code to do the analysis and the results, things like that. The easiest way to work with Jupyter notebooks is a program called interact.io. It's an Electron app that kind of wraps up the whole Jupyter lab environment. Traditionally, when you work with a Jupyter notebook, you have to run a server and normally Python. So, this makes it a little bit easier to install a single app. And so let me show you here. And so you can run R at kind of the console. See if we could, no. So we can run R at the console, and it'll give us the opportunity to log in, and we can do 1+1. We can do vector things. C 1, 2, 3, 4 +5. R is a very vector-based language, but we don't really want to work in that. We want to work in a Jupyter notebook. It's a lot easier to do 1+1 here, or same thing, 1, 2, 3, 4 +5. And then we could count the results, and we could go back and change these at will. To do this, though, not only do you have to install Interact, but you have to install the IR kernel. It's super easy. You just run these two lines. You just would copy and paste them in here. And it'll ask you for a cran mirror, and you can kind of choose whatever you want. It doesn't really make a whole lot of difference. And then it downloads the package and installs it. And that's really all you have to do. So I'm going to cancel out of this because I don't need to install it again. If it'll let me cancel. And so now you should have, if you've installed the R project, Interact, and IR kernel, you would now have this kind of environment where you can start a notebook. And so the first thing you really need to do if you're going to work with DBR data, VCDB, VERIS data, is you need to install VERIS R. And this has a couple of tools that are critical for working with DBR data. And so you can do it in your notebook. You just copy and paste this line in there. Actually, before that, you have to install DevTools. So you're going to want to do something like install.packages, DevTools, and then it's also smart to install .packages tidyverse. And I'm going to reference a lot of things that are part of the tidyverse package. The tidyverse package is a aggregate package that installs several other things. And so if you install these two, and in fact, DevTools might be part of tidyverse as it is. And so you install these, and then you can install VERIS-R. And that should really be the main set of what you need. And so, notionally, you'll have, hopefully you've been using kind of the same process I demonstrated earlier to code your kind of incidents into the structured JSON using the web app. And then but we're going to analyze the JSON in VCDB. And so this is a repo, this is public, anyone can get here. Data, and then you're looking for the JSON data, or we're going to work off of the JSON data, and we're going to work off of the validated JSON. And there's too many in here to show. And so what I'm going to do is off screen, I'm going to put the directory, this is on my local machine, into a variable, and then we'll load that data. So VCD directory, and blah, blah, blah. Yeah, I remember exactly where I have it stored. Data, JSON validated. Okay, and so we define this directory. We'll run that. Then I'm just going to replace it with path2. Oh, I need to do this. There we go. And then path2 VCDB. So we've got that stored. And then the first thing we want to do is we need to load the data from the tabular format, the JSON, into a data frame. From the hierarchical data, the JSON, into the tabular format. And we do that with VERIS-R, JSON to VERIS. And I'm going to define another variable here. I need to define the schema location. And the schema in VCDB is in the root. You want to use the merge schema. And it's really the exact same one as the one used for the DBIR. And so we're going to need that as part of JSON to VERIS because it tells the import script how to create the columns. So we're on VCDB here, and I'm going to define the schema location off screen as well. I got to type all this stuff in. I really should use less verbose directories, shouldn't I? Merge.json should be the whole thing. And I made a minor error there. So we define that, and it's now path2. So we'll just put another path2 placeholder in here. Put this over here. And then, so we've got something like this, and then we do, we can look at the then I think this is directory equals, and then schema equals schema location, and then we'll just run that. I'm going to run it off, start it off screen so that any errors don't pop up. And so it starts running, and it's going to take a little bit of time. We're importing about 8,000 files here. For reference, the DBIR, when this runs, it takes about an hour because it has to import, per year it imports 50,000 or 100,000 rows. In fact, we've gotten to the point where it takes so much time that we actually create the data frame separately because some of them, like our archive data frame, it has to be generated in the correct schema every year, but it doesn't, it takes so long to recreate the other 600,000 rows that are in the data set it's just not worth the time to regenerate it every single run. And so for VCDB and our archive of data, we only create the data frame of them once, and then in our nightly runs, we recreate the new data as we kind of add to it and fix it and things like that. So now we have a data frame that is 8,000 rows, 2,500 columns. We're going to load the tidyverse. We do that with library tidyverse, and this gives us most of the tools we'll need to do our analysis. And so the first one we want to use is glimpse, and that lets us look at our data frame. Hey, Alex. So it is 8,000 rows and it will show us all the columns which we, maybe don't want to do. And an easier way to look at this is using dimension. And so the base thing we're going to do a lot of we're going to follow kind of a very simple structure when we do analysis. It's going to be something like VCDB, and then we're going to use the filter function from dplyr, which is one of the packages that we loaded. And I'm going to put in here the field that we use to define breaches. And the DBIR and in VERIS, breaches are any disclosure of unauthorized data or confirmed disclosure of unauthorized data to a third party, or unauthorized data to an unauthorized party. Ugh. And so we record that in attribute confidentiality data disclosure yes. And so this gives us just the breach data. And so we can do that, and then we can do dimension. Confidentiality data. Confidentiality data disclosure yes. And so this is an opportunity to do something. Do this. We can do. This is how I always find columns when I make a mistake. Is you can grep for disclosure and names VZ. Oh, it's looking for the object, which probably means I didn't feed this in right. No. Oh, did I misspell it? Yeah, I did. Oh, this is a good excuse to. Thanks, man. To show this, and VZ is not the right one because that's the one we use for the full data set, so VCDB, and there we can go. And so this is a good way in R to figure out. And by the way, when you've got like 2,000, 2,500 columns, you're not going to remember them all. If you feel this is too many columns, I highly recommend sending all complaints to Jay Jacobs. It's his fault. I say that jokingly. Like, we actually have an interesting conundrum in our data because it's hierarchical. You can have multiple values for any given variable. And so in this case, these are all kind of exclusive. But if we were to look at like the action, so if we're going to look at the action, it could be both hacking and malware and confidentiality. So we can't have a single column that's just called action because it has to have multiple values per row. And so what we have is we have multiple Boolean columns. So you have an action.hacking column and an action.malware column and an action.error column. And this is how we solved the problem of getting hierarchical data in a tabular format, where it comes out in importance is you need to be careful as you do your analysis, because the traditional way, right, is to count the number of each value, the number of hackings, the number of malwares, the number of errors, and then add them up, and then use that as your sample size. The problem is that's not your sample size because you've now counted multiple of the records multiple times. And so we have a tool for that I'll show you later as part of VERIS R that does a lot of the detail work for you. So we'll get back to what we were doing. VCDB, filter, and I am going to bypass my traditional area of weakness, spelling. and just copy and paste. And there we go. And so this is the tool. Actually, before I show you the tool, I want to talk about this. So I'm using this tool called the pipe. And it actually comes from a library called Magritter. And so Magritter was imported with several of these other tidyverse packages, and so you got it inherently. Did I misspell it? Oh, it just masks it, is what it's saying, because it was used in some of these others. This is extremely helpful because it lets you take the output of this function, in this case the data frame, and make it the first argument of this function. And then it takes the output of this function, makes it the first argument of this function. And so effectively, kind of what this has done is it's made dim, and then filter, and then VCDB. And so this is kind of a pain if you try to type it out, particularly as it gets longer. This operand makes it very easy to work with and lets you kind of do things functionally in a sequential manner. And it's a huge part of making R an easier language to work with. And so we get to that. And then the function that most VERIS stuff comes from is verisr getenum CI. And the CI stands for confidence interval. And this is based off of functions that were around before I was. I've gone through and rewritten parts of it, improved it to handle things more consistently. And so let's start with the most basic enumeration that we ever do on the DBR. Get enum action. And this goes and counts. And so what it did when it counted up the sample size in is it didn't add all these numbers together in the X column. It counted the number of rows. One of the things it did is it removed the unknowns. And you notice they're not in the sample size. And excuse me, that's because on the DBR we treat unknown as not measured. Because we don't know, it could have, each one of those records that only had an unknown could have fallen into anything. Now, if a record had an unknown plus a physical, it would still get counted in the sample size because it did have an action. Let's see. And so we add this up, and we can kind of see what the most common actions are in breaches in VERIS. And over time, it's actually errors. Now, out of 5,000 breaches, errors happened more often than anything else in VCDB. In breaches specifically, we can also remove this and talk about incidents, and we get 8,000, and yeah, still get errors. And so now we want to kind of do a little more analysis. This is like the first step. And really, we talk about in the report about subsets. And so there's everything, and then there's the things we really want to analyze, things that really meet our criteria for analysis. And those fall into subsets. And so we can grep for that. Subset names VCDB value equal true. Oh, and there's no subsets built directly into VCDB. That's a shame because the subsets filter for a couple of things that I guess they really aren't that relevant for VCDB because they kind of are things like, you know, a whole lot. We talked about in the DBR how we had 50,000 botnet breaches, and if we'd included them all in the data set, it would have swamped it. But that really doesn't apply here because they came out of a different source. And so we don't have to put any filters, but generally what we do is we'll filter here and we'll do plus dot DBR year equals maybe 2019, or maybe we'll do in the last couple years, say 2017 to 2019. And then if there's any subset, you would put it here, subset dot blah. And of course, what the filter function is doing is it's removing any row that doesn't match this criteria. And so this is a logical vector. It's just trues and falses. And any row that has a false for this gets removed. Similarly here, any row where this, the plus.dbir year column equals or in this evaluates to false gets removed. And if you had a subset column that was illogical, those would get removed as well. So we'll look at the last 3 years. And error's still at the top of breaches. And so let's go and investigate the other 4. There's 4 things that we think of as kind of the primary things For the DBR, they're the action, the attribute, the asset, and the actor. And so we'll start those down here. By the way, you don't have to do this, but it is incredibly recommended that, let's see, it's UUID generate, yeah. That anytime you do some analysis, you label it. This has been one of the huge things that we've done in the last 2 or 3 years, is that anytime we generate something that we're going to share in any way, we identify a UID with it, so that if we ever have to go back and figure out where it came from, we've got an ID or something there. And so let's look at some of the other characteristics. We can generate other UIDs, and this is a package you'd have to install. You install it with install.packages, the same way you did the tidyverse up here. Add a UID, and I'm not going to add a UUID for each of these since we're never going to share them, but it is very good practice. In fact, I'm going to make a section down here, and the text box is a markdown field. This is a code field, and so we could put say setup, and then we can tag maybe analysis. And then down here, we'll put backup stuff. So I guess I don't need 2 of these. So now let's look at actor. And we see mostly internal actors, and that's not unsurprising given that we're dealing with errors. Do the same thing. We can just copy and paste this code. Do asset. Oh, sorry. Asset is a little bit different. And it has to do with a weird idiosyncrasy of how the schema works. But it's actually asset.variety. Again, not my fault. I say that, but like I've looked at trying to make it so that it would work the same as all the others, and it's not easy. So I certainly, like, I may not have been the originator of it, but I certainly haven't brought any solutions to the table either. Okay. An attribute, confidentiality, and the reason confidentiality is in all these is because we sub-selected for breaches. That's always going to be the case. Now, something else we can do is we can assign a CI method. In this case, we'll try Bayes. Bayes, the package we use, has some errors sometimes with Bayes, and we'll try to get off of it in the near future, but currently we kind of work with it. And by putting a CI method, and it defaults to a 95% confidence interval, we can kind of see the range that we're dealing with. In this case, our sample size is very large, and so our ranges are very small. 99.8 to 1, 24 to 29%, things like that. And by the way, if you want to make these prettier, you can do something like mutate. Mutate assigns a column the value from something else. So lower equals scales percent lower. Upper equals scales percent upper. And we might as well do frequency as well. Frequency equals scales percent frequency. Yeah, now we have nice pretty percentages. The problem is now they're not numbers, and so you won't really be able to do any calculations on them, which is what we would want later. And so we'll go ahead and comment that out for now. And so going back to action, we looked at the top actions, and that's fun, but what we really might want to know is, actions up here, is what really action varieties we're dealing with. And so what you can do is you can assign a star, because what's happening under the hood here is this is getting plugged, the string is getting plugged into a regex that is used to choose the column. And so the star equates to this block right here, which is really hacking slash malware slash errors, all the other types of things. And so here we can count all the different varieties together. But it might be helpful to know where they came from. So we're going to say short names equals, actually we'll start with short names equals true, so you can see what that's like. True. And there's a lot of actions. In fact, you can see right here, it filters them out. And so maybe we only want the ones where something actually happened. So filter x does not equal 0. And it's still cutting us off because there's so many things that have happened. But now we could it's a little easier. We can look at the top ones, obviously. Privilege abuse is the most common action, and so that's going to be, I think it's a misuse one, but right, it doesn't say over here. And so the question becomes, how would you go and tell? And that's what the short names is for. By default, it shortens the names to just the last segment. So action.blah.variety.x, and x is what goes in here. So we'll set this to false and we'll rerun it. And now we can get the full name. And it's a little less, it's not as easy to read, but it also tells us a little more. And this becomes very important when we do things like actor motive. So we'll come down here, we'll do actor.star.motive, and short names equals false, or equals true. We'll start with true. Well, no, I'm going to start with false because it'll be more clear what's happening. Oh, and that's a good point. The system is set up to force you to choose NA if there is an NA enumeration. So there are times where there's no motive, right? If you make an error, then the action was inherently unintentional. If it's unintentional, you can't have a motive for it. When that is the case, the getEnumCI function will force you to choose how to include not applicables. So if I were to, and it depends on your hypothesis. And so if I were trying to answer the question, what motive is most common, I would probably want to remove NA from the sample because there aren't any motives. So NA.rm equals true. And you'll come down here and we'll see that there are NAs for these motives. On the other hand, if I ask the question of, what, how would you phrase this so that you don't actually mention NAs? What percentage of all breaches are motivated by blah? Yeah, exactly. The X or the percentage that are motivated by blah, so that your sample is all breaches. Well, then you want to set not applicable to false because you want to include the not applicables in the sample size, and then you see it gets moved up here. But another thing you'll notice is that we have actor_external.motive.financial separate from actor.internal.motive.financial. A lot of times we just want to ask, what percentage of breaches are motivated by financial, regardless of internal versus external. And that's where the short names function really makes a difference. So if we set this to true, and I'm going to put this back to true since most of the time we don't want to include the NAs. And an important one to pay attention is to always include NA when you're choosing country, because NA in the country is the actual country of, I think, Namibia. It is not applicable. So we come back here, and now all the financial ones are aggregated together. There's no second. So when you set short names true, and the enumeration occurs in multiple different parent types, and so internal and external, it aggregates them together and counts them correctly. And that's how we get things like the percentage of breaches that are financially motivated. And you have to be careful because you could have both an internal actor and an external actor that are both motivated financially in a single breach. And that would still only count as one financial breach, right? And so you can never add up the X's, or you have to be very, very careful about adding up the X's. You have to know what you're doing. Otherwise you get incorrect sample sizes, which leads to incorrect frequencies. And really incorrect confidences as well. But now we know the financial. But, a lot of times it's hard for people to see, to just kind of look at this and know the difference between these. And so one of the things we may want to do is analyze it to, visualize it. And so come here, and instead of saving this, the nice thing is this is just a pretty nice structured data frame. Excuse me. So we're going to use a function called ggplot, or a package called ggplot2, to do our visualization. And this isn't going to look like kind of the visualizations I traditionally do, because there's a million other things that go into those. They end up with being these like 30-line functions plus to do. But it'll give an idea, and particularly for anyone wanting to do some kind of basic analysis and produce some basic visualizations, this is a good way to do it. And so what we want to do, by setting the pipe, we are sending the output of this, which is this data frame, in to the function plot. And so now it effectively gets assigned to a variable called data, or to an argument called data. And so now the data is in our plot. And now we need to add the other parts of our plots. So the next thing we need to add is a geom. In this case, we're going to add geom bar, which is a bar plot. But what we haven't told the figure function is how to make the data show up in the plot. It knows it wants to do bars, but it doesn't know how to create them. And so we're going to use a function called aesthetic, AES. And we're going to say the x-axis we want to be the enumeration. And the y-axis, we want to be the frequency. And so, you know, x's will have all the enumerations along the bottom, and frequencies will go up. And we have to actually tell it for this geom that the stat we want to use is the identity of the value. And see, it removes the ones that have NAs. And did I do something wrong? Because it should not take this long. Short names equals true. Let's try this again, because it is stalling out on something that it shouldn't be stalling out on. Huh. Why would it have time doing a bar unless I'm just, unless it's just being ornery, which may be the case. And so this stacked, and one thing you'll notice is that the largest one is on the right. And that's actually for a specific purpose. The data coming out of, let's see, the data coming out of getenumCI, this column is actually a factor. It's not a character vector. And factors in R can be ordered. And in this case, it's ordered with the highest one last. And the reason is because we rarely show bar plots like this, because you get stuff like this where the names start bumping into each other. And so we actually tend to flip them. So we're going to manipulate the coordinates of the bar chart. And when it does that, it takes the rightmost one and puts it at the top. And so you have to actually sort them backwards. And so now we've got the bar chart kind of the way we want. But there's a couple things that kind of look, you know, let's say that could be improved. So let's do some basic improvements here. The first thing I want to do actually is I don't like these labels. Like, we want actual percentage labels. So we're going to do scale y, because at this point we haven't flipped it. And it's going to be a continuous scale because these are continuous numbers. And more specifically, the frequency column is a continuous variable. We're going to say the labels, and we're going to define a function we want to use for the labels. Scales format, what's it? Percent format. We're going to set accuracy of the percentage to 1. And so when we do that, and by the way, notice that when we start working with figures, we have to switch from the magritter to a plus sign. But now we have actual percentage labels down here, which we wanted. But we've also got all this kind of junky extra space, and we've also got the NA and the unknown that we don't want. So let's filter those out. Filter not is NA. In, and that we'll get rid of the NA and the unknown. And then let's get rid of the extra space. So expand equals C00. And we'll also have to add another scale here. Down here, because we'll need to add a scale for the x-axis to get rid of its extra space too. X, and this is going to be discrete, right? Because we're not using, we don't have a continuous variable. like these numbers all are continuous. You can keep subdividing them down. Obviously, these are discrete values, and any character vector or factor is likely to be a discrete value. And so we're going to do the same thing. Expand equals c 0, 0. For the longest time, like I saw these in every plot I got from the DBR team when I just joined. I'm like, why in the world is that on every one? And the reason is because it looks ugly without removing them. So now we actually we got rid of that extra space and the extra space down here, but these tick marks still look kind of silly. And so we're going to modify the theme a little bit. And the theme function is a really nice one. You have a lot of theme characteristics, and you modify them all by assigning them to an element. And so in this case, we're going to do the axis.ticks, I think is the right one, equals element blank. That should remove the axis ticks. Yep. And you know what we probably want to do is we probably want to take the panel background, which is the gray area, and get rid of it. Black background, I think is right, equals element blank. But now we don't really have as much stuff. We would like more. And so let's set our panel.grid.major equals element line, and color equals gray 85. Now the important part is that you always set everything to gray 85. No one knows why. You're just required to do it. No, it's just a good color that goes with kind of the rest of the stuff. And so if you're like, of all the things, you just kind of remember it and it looks good. But now we don't really need a line that goes across other, right? We know that that's other. There's a bar there. And so we're going to set the color for the major grids, but we're also going to set panel.grid.major dot y equals element blank. And now we have the grids where we want them. Wasn't that nice? And now we've got, a nice chart, except we've still got some weird labels, right? Enum and frequency. That doesn't make sense to anyone we'd be showing this to at work or anything. And so we probably need to fix that. And so why don't we go back up here, and probably I kind of tend to add these up near the data and say labels, and we should give it a title, shouldn't we? Like, you should title your charts. And so this was motives, well, we'll say breach motives, because these are breaches. Breach motives, or actor motives. Actor motives and breaches. And I really try to kind of capture as much of the as many of the filters as possible. Try to, as holistically as possible, capture the filters in the title so that no one ever makes any assumptions about what was or was not in the data. It's not always possible to get a nice succinct title that way, but it's preferable. And so let's call the x-axis in this case, it's going to be frequency or percent. But I almost feel that that's redundant. Like, do you really need to tell someone that 40% is a percent? So maybe we'll just remove that. And then the y-axis, we could label these as breaches, because we know that these are breaches. And so, I put this above the chord flip, and so these are backwards. So we'll remove this, put it over here. So breaches is over here, but actually now that I think about the way I had it before, like, it doesn't make sense. I don't have a lot of space horizontally, and it doesn't make sense to kind of have some of the text going vertically and some horizontally here. And so because I'm not actually putting any labels down on the percentages, because people know what percentages are, we can actually put it down there. And it actually looks okay, but kind of looks okay. But I don't like it here in the middle here, so I'm going to do this axis dot label dot, in this case, x equals element text line, or was it h just equals 0. See if that works. Nope. It's not access.text, because that's the actual text. So what actually is it? So we can go over here and ggplot to theme. And we'll look at the documentation, which sounds like a much better idea than, pounding our head against it. It'll access.title. That was close. There we go. And now it's aligned where we want it to be. And you can change in here. You can change the font format, the colors. You can do all sorts of stuff inside of these element boxes. And so now we've got kind of a nice chart. In fact, there's really only one thing that we haven't done that would be helpful to do. Let me see if I can find, because I know I wrote the code down for it. Here we are. So this is not the chart size figure you're going to put on a chart. Yeah, no kidding. This is like, so on the DBR, actually, like, I spent a whole bunch of time getting that one perfect looking bar chart, and then I functionize it. And the nice thing is, because get-enum.ci always turns out the same analysis, it's really easy to build a single function around the figure itself and just feed the output of this into a single function and always get those really nice bar charts. Otherwise, like the figure report's like 4,000 lines already. And it has 50 bar charts in it that would be 30 lines each if I had to type them out. But yeah, it's important to make it pretty because no one cares about what your analysis says if it doesn't look pretty, unfortunately. Okay. Let's see here. And so the problem is this isn't really the size you want to put on a chart. Does anyone off the top of their head remember the size that charts, like actual PowerPoint charts are? It's something like 7 inches tall, I think, and maybe 13 inches wide. Is that right? And I have these backwards. If anyone remembers in chat, let me know and I will do it appropriately. But this will then size it to the chart you want. And by the way, this will apply to all others. It's kind of it's a setting that applies to the entire notebook. The other thing you could do is you can save this to disk, and so something like this, and then gg save gg, and then width equals 13, height equals 7, and then file equals whatever, and that will save it to disk in the appropriate size. But I find this helpful to just set the setting to the appropriate size in your notebook. That way, as you do the analysis, you get figures kind of the right size. And then as you were doing this, you would want to kind of adjust the text so that it's the correct size, making it a little bit bigger. But yeah, this is like, and this is so much of the analysis is just these 3 or 4 lines, right? It's not profoundly difficult with the tooling for someone to go in and look at it. Now, as the questions get more complex, the analysis gets much more complex very quickly. But the easy questions are meant to be easy to answer. Now, one other thing I want to show before we go, because it's about 45 minutes in, and I don't want to go too long, is a line chart. And so something over time. And so let's say that we took this back to 2015, maybe. That's a decent amount of time. And we wanted to see what the trends were over time. We can still do that in get-enum.ci, and I'm going to remove this line for now. Well, actually, I'll leave it in. We can do by equals plus dot dbir year. And by the way, the reason it says plus dot dbir year, there's a couple year time values in VERIS. Timeline.incident.year is 1. And so if you want to know what happened in a specific year, you can use that. DBIR year is the year that it was added to the corpus. And that's very important because some breaches take months or years to analyze, and you want them counting in kind of the correct spot temporally. And so when we, excuse me, when we do this, and we could do this with anything here, and I'll show that in a minute. We get our timeline and our enumeration and then our values. And when we say by sets the sample size. So you notice all the 2015s have the same sample. That's because this is financial out of breaches that happened in 2015, fun out of breaches that happened in 2015, etc. down the row. And so you get this, but this is impossible to consume visually, at least as a table. And so we'll definitely plot this. Same thing, we'll add the plot and use Magritter to add the data to it. Geom line. The aesthetic is X, we want to be by. Y, we want to be the not the enumeration, the frequency, so that we're going across with time and we're going up with frequency. And the final thing we want to do is say group equals enum and color equals enumeration. And that makes each, because it has to know which points are part of which line. And the group tells it which points are part of which line, and the color tells it to make them all a different color. And we'll run this, and we'll actually get an interesting thing here because we will get a legend as part of this. And then there's a lot you can do to control the legend. There's a lot you can also do to control the color within ggplot. You'll have to look into the ggplot documentation to kind of get a better idea how to do it. But this gives you a basic idea. And even here, we can start to see what's happening. Fun has really been going down. Espionage has come up, even in the DB or in the VCDB data set. But of publicly disclosed ones, financial still takes the cake, and it takes the cake in the DBR as well, right? Because most attacks are financial. And so now we can see how to show this over time. And we use basically a form of this. It's nice to smooth them out, but the function that does it for the DBR is really a rather complex one, because it sets all the splines. It creates a smoothing function, but it sets all the control points for the splines on its own, and it does a couple things to try to make them look a little bit better. So it's kind of weird. It's meant to mimic one of the D3 smoothing functions. And so now we have kind of the analysis over time. But we can do this with really anything. And so what might be a little fun is to look at maybe what's the motive by the action. And we'll go back to the 2017 data set that we were working with, 2017 and 2019. So now we've got this. And by the way, you'll notice that short names doesn't apply to the by section. And so we're going to do a little bit to make this a little more readable. The first thing we'll do is we'll fix the by. So mutate by equals stringer, string sub. And what we're going to do is we're going to take a subset of the string, and we're going to manually count 1, 2, 3, 4, 5, 6, 7. And so we want to start at the 8th character of by. And if we knew what the end character was, 12 or whatever, we could put it in here. But if we put nothing in, it just goes to the end. And so let's take a look at that. There we go. We've got much better things over here, but this is still illegible. Now, frequency, again, that's not a really useful way to read frequency. So we'll take frequency equals scales, percent, frequency, accuracy equals 1. And now we have nice percentages, but again, it's still not usable. We can't show anyone this table. So we'll reshape it. Reshape 2, decast. And we're going to cast the enumeration by the by value, and the value var equals the frequency. And so we're going to lose a little bit of data. We're not going to be able to see the in value or the x value, but we'll be able to see what we really want to see, which are the values. In fact, if you wanted to display this data, you would display it as kind of a heat map, which we've done several times in the DBIR. And if you wanted to go in, you can complete these. There's a tidyr or a tidyr function to complete it, to make sure each one of these cells is a 0. That way you have a value at every intersection, and you don't have any of these NA percents. Actually, those are only in the NA, so we can actually get rid of that by filter NA dot not is NA in. And there's nothing in environmental but it got rid of those top two rows that were all NAs. And so this is a little more legible. We can see the values down here and the percentages, and get a bit better feel. Still, like 80%, 90% of social is financially motivated, but misuse, 23% of misuse is motivated by fun. Right? That's kind of interesting. In fact, very little, of course, error is motivated by financial. The only cases where you'd probably have that is when an error was also had a malicious action by an external user as well, and they were financially motivated. There are errors associated with convenience, though that's probably more of a misuse thing. And then fun. So we can start to see how to look at two categorical variables across each other. So there's about 10 minutes left. Just out of curiosity, does anyone have any questions before I kind of wrap it up for the day? This is good basic analysis. If you were a organization who had, just spent some time coding incidents into VERIS, you could go and do this. Instead of using by action, you might want to look at something like, and I'll just move these. What was the action of the attack? And I'm going to put industry in here. But that could potentially be your departments within your organization. So you could look at how does the action and breaches vary by departments in my organization. And we need to remove off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we want to start at figures 18, I think. And these are NICS codes up here. And actually, I think, would industry name work? I probably don't need this either. Nope. It was worth a shot. So we go back here. And these are, I call them NICS codes. We could see how the actions vary. 0, 0 we use for unknown. 11 is all misuse, but that's probably because it's a pretty small sample size. And in fact, actually, that would be kind of cool to show. So one of the things that we're trying to do, of course, is talk more about confidence, right? Because that is probably not absolutely 100%. So instead, what we may want to do is show a margin of error. So ci.method equals try base. And I'm going to put something in here so we can see this. I'm going to tee off the variable and print the data frame. So we'll get an intermediate value. This is what the data frame looks like. And now we've got this upper and lower. And so what we may want to do first, or let's see, we want to do it after the percentage here. But before we reshape it, is mutate and make frequency equals paste, which is string concatenation. Frequency, and then we're going to take upper minus lower divided by 2. And we're going to turn that into a percent as well. Scales, percent. And then a accuracy equals 1. I think that's enough. Look at that. Actually, I'm going to comment out that extra line in there now, since we've seen it. Oh, and I wasn't piping it. So you can put like an intermediate thing in like this, but we are just going to remove that. Instead, use the normal process. Oh, and what we wanted to do was make paste 0 and put in comma plus minus percentage and accuracy. Oh, I have the accuracy in the wrong spot. That's why. So accuracy should be over here. Here, and so now we could kind of see where, you know, here it's very accurate in 92 because there's a lot of breaches, and that's because 92 is the public sector, and the public sector has to disclose breaches publicly. Same for healthcare. You know, we've got plus minus 3% or something. You know, you get over and look at like 11, which I think is, it's not utilities. 11 is mining. That's what it is. And there's not a lot of breaches in there. So the confidence interval is like plus or minus 30%, right? Because basically there's probably one breach. And so it's either 0 or it's 100. But that's with like 80% within the confidence range. And so you really can't trust these numbers at all. And that's why it's very important to pay attention to the sample size and confidence, in which we're trying to express better in the DBIR. So anyway, this hopefully gives a quick overview of how to start doing analysis once you've got the data, how to set up your environment, import the data, look at some basic features of it, actions, actors, and you can look at these varieties for anything. Actions have varieties, actors have varieties, attributes have varieties, and assets have varieties. You can then make bar charts out of it to share them and show them in a reasonable view. Like you could go and set the bar here to, you can set its fill value. Fill equals, what is it? Steel blue? Steel gray blue? Try steel blue. That may not be the right color name. Steel, I guess not. We'll just say blue. As an example. Oh, did I? Oh, because I started putting it in here, so maybe steel blue was correct. Well, I already used that color, though. I used it for the line. See, I can't use it twice in the same figure. Actually, steel blue is kind of, it's almost an inside joke, because that's what that was the color that was used for all of the internal DBR analysis. And so, like, I've seen it so much since I got here that I'm kind of sick of it. But it's not a bad color. It's kind of a nice kind of unobtrusive blue. But, you know, if you're doing this for your company, you may want to use the colors. You wouldn't want to go overboard. Like, making all your bars a color is good. Setting the bar to here, fill equals say enum. This is bad because this color doesn't tell you anything. You already knew that this bar was financial, so why do you need a color and a legend to tell you? Like, all this does is it confuses people, because they go, well, you know, the color already represents the word represents the bar. So maybe the color is the importance, and like light colors are less important and dark colors are more important. You know, and then they spend a bunch of time trying to figure out why you colored this weird, and they spend very little time paying attention to what you actually told them. Instead, just use one color. Use steel blue. The only time where I've actually used the different colors is if you're going to break these out. So if you're going to do an entire section of writing about financial specifically, you could use a single color for that. And then you could go and use that color. And so if I used green for financial, I could write an entire section on financial, make all the figures in that section green. And it would be a good tie-in between this figure and then that section. Or stacked within each bar by some other variable. I'm not a big fan of stacked variables. I think that a lot of times people, like, they're hard to read, especially unless you put a lot of thought into them, because you can get a whole bunch of small categories within the bar. Oh, yeah. And did you see Bob built the bars with, like, the chiclet edges? The rounded edges, which I actually thought did a really good job of separating up bars. So if you're going to do something like that, and then we had an funny, and then we had an intern who he actually used Geom highlight with a bar chart. So he highlighted like the top portions of the bars, the enumerations that made up the majority of the bar, and it actually worked out really well because you got 2 or 3 colors in the bar. so it was still consumable, but you still got the effect of all the different pieces. And so you were just looking at the top values. So there's some really cool ways to do it. And so with that, I think I'm going to wrap things up. Thank you, everyone, for coming. If you have any questions, by all means, hit me up on Twitter at GDBassett, or you can send emails along. I'm happy to answer questions, and if you've got anything that would make sense or you'd like to see me do in the future, please let me know. I'm trying to do a better job of kind of sharing how this is all done, because we want other people to be able to do it for themselves. And so I'm happy to help. Thank you all.